Alright guys, this is my numerical calculation standard and I created just a simple vpython program that measures the projectile motion in which a baseball is thrown from outfield to second base. As you see right here, this sets the characteristics of the ball, gives it a position vector of -2 on the x-axis, 0y, 0z, a radius of 0.1, and I gave it a color of yellow. And I attached the trail to it just so you can see the motion in which the ball is thrown. And right here I create a ground just so you can see where the ball is thrown to where. I have a ground. I created it out of a box, giving it a position of 1 in the x-axis, -0.02 in the y, a size of 9 in the x, 0.5 in the y, 0.5 in the z, and I gave it a color green because grass is green. Here I get the mass of a baseball, which is actually 0.145 kilograms. I have my gravity variable right here, -9.8 in the y direction because gravity is only going up and down, or going down. And my initial velocity of the ball is 7.0. I have, and the angle in which the ball is being thrown is at 45 degrees. And right here I'm calculating for my momentum, which is the mass of the ball times the initial velocity times the vector of the theta, and this is where it's being converted right here, pi over 180. And this is where I set my initial time variable. The change in the time is right here. And then everything is going through my while loop. So it's saying, well, the initial time is less than 5 seconds and the ball dot position of the y is greater than or equal to 0, then it's going to execute all this through the while loop. I set the rate equal to 50, and that's pretty much the speed in which the ball will be thrown. So my first formula it goes through is F is equal to m times g, so that's just ball dot mass times gravity. That gives me my Fg. And then I calculate for the ball's momentum after the ball is being thrown. So that's ball dot momentum is equal to ball dot momentum, that's the initial momentum, plus the net force of the ball times the change in time. And then I calculate for the position of the ball, which is ball dot position, and then equals to ball dot position, which is the initial position, plus the ball dot momentum over the ball of the mass times the change in time. And then I set my initial time equal to the initial time plus the change in time, and it does this. Let me run that again. All right.